Hey guys, just a minute. I'm trying to work it out in a minute. We have technical issues a little bit. This is a lot of technology. We are going through a lot of technology issues. Uh, okay, good morning, good evening in California, good morning in India, good evening in California. And let me, these live streams are challenging. It is so challenging. It is a we are the guest problem is the guest, the content, the you have to on the buttons, and it is really frustrating. It tests your patience. It tests your innermost soul. I tell you that. And and even if I give you the advice, they don't care. So this the future, they don't understand. Whoever catch it's a Zoom caught the future, they immediately jumped into the advantage of this process, and then they took advantage of it. Other companies, they don't understand. They're not taking advantage of it. They need to take advantage of it, this situation, because a lot of people don't want to go to the see in person, because there is several reasons: comfort, convenience, and other things. So so it is a kind of a challenge for me. um, you know there is a you know I I don't know. I take my energy, every bit of it, and then I do it. I try to um, educate people in the doctors, give it tools. I'm trying to make neo polymath. The new doctors need a different kind of innovation tools. MBA doesn't cut it. MBA gives you operational efficiencies, how to take advantage of the existing system. It doesn't give you the new tools. New tools you need: physics, mathematics, quantum mechanics, quantum physics. You don't need to be expert. You need to be exposed. You need to know enough where to go and get it, where to go to get the help. There is something like existence that exists. That's what I did with the technology and other things. Medicine, that's what I did. I don't know medicine in and out, but I come to know enough. I learned myself enough to explain to the doctors. That's good enough for me. So I'm not a doctor, so I don't have the that I have enough knowledge to explain, um, to the I have enough knowledge to explain the process. That's what I learned about medicine. So the doctor should do that, because that's otherwise we're going to have a stupidest, unnecessary technology companies. They have no clue about healthcare. They will come and take over. You will be working for them soon. Not far from there, 5 years from now maximum. So you need to really proactive in this area. Understand them, understand the technology, understand mathematics, understand physics a little bit. I'm not asking you to be expert. Just get familiar with it, because you have the discipline, you have the intellect and discipline. You can learn. Doctors can easily learn. So CEOs can do that too. So this pandemic taught us how to be in all these things. I started this program. It's a lot of pain. I snail pace. I'm started doing this slowly by one. Today I'm going to talk about very interesting topic. So I'm going to make it quick for you guys, because let me talk about the topic. Milton didn't show up. um, I don't know, some technical issue I have with the links, and maybe he's busy. So I hope he will show up one day. You know. So I want the guests, if they don't want to show up, just let me know in advance. That's all. I want that respect. I give respect. You give respect. I'm promoting you for free. So that's one thing I ask people. But anyway, this is the thing that I want to talk about. A universe. How do you laws of the universe? There is the laws that work in the beginning of the universe, right after the Big Bang. The laws that we can tap into to cure the cancer. I'll tell you what that is. It's surprising to you. It's very interesting. So Before I do that, I wanted to. Yesterday, there was a Nobel Prize for physics was announced. I'm a physicist, so I got to talk about a little bit about. You need to know. Even the doctors should know. This is a little bit about this. The alien aspect. J.F. Clauser from alien aspect from France. John Clauser from California, in fact, and Anton Zellinger is from Austria. They won the Nobel Prize in physics. So the thing is that um, what they win for is very interesting. I will explain to you in a simple. You have to learn why they what exactly in the simplest, very simple terms. I'm going to explain to you. So these are the brother and sisters. They the sister goes to school, went to school in University of Georgia. Brother went to school in Vanderbilt. They play football games with each other. The University of Georgia is Bulldogs, and Vanderbilt is Commodores. They have a rivalry, but Bulldogs is way better. But I don't want to say to my son or the boy in the picture, the guy in the picture. So So what is happening in quantum entanglement? I'm explaining through bulldogs and commodores. These two kids, when they were so there is something strange happening between them. This is a story. I'm telling you, story. It's not real. It's thought experiment. So when she wears, the girl wears UGA shirt, the boy wears Commodore shirt. When girl wears Commodore shirt, boy wears UGA shirt. Automatic. They don't call each other. They don't text each other. They don't phone each other. Nothing. There is no communication. So they're doing that all the times. So it's like a magic. Is there any telepathic powers they have? That is a question mark they have. So that is happening. The quantum physics says that is a telepathic outside of the our universe happening. We don't need to know why it is happening, but it's happening. The fact, take the facts. So, but Einstein came in. He didn't like that idea. There is no telepathic nonsense. There is. It is happening because you. Yes, I agree. They didn't call each other. They didn't text each other. They don't have the phones. This is a thought experiment. So Einstein says this is all nonsense. There is no telepathic anything. They made a pact between before they go to college. When they were in high school, they made a pact. The hidden pact. Hidden pact is when you Monday you wear Commodore, I will wear Bulldogs. Tuesday you wear Bulldogs, I wear Commodore. So they made a pact. So looks outsiders is random. They didn't call each other. There is no text. People who saw them, they think it is random because there is nothing. There is no communication between them. So Albert Einstein says that they made a pact in between. They had a hidden pact. They made it before they went for college. They made a pact like this. So that is you need to investigate. You don't know the complete story. You need to investigate that what that quantum. So the quantum entanglement is that like that. A particle goes spin down, other one is spin up. When they don't, when automatically even a billion miles away, they one is spin up, one is spin down. So so um, yeah. So one is spin down, one is spin up. There's two particles, even two photons. They can go a billion miles away. Still, they are instantly doing that. So there's no telepathic, is no communication. There is no impossible instantly doing that. There is impossible to light travel faster than speed of light. There's no communication can go faster than speed of light. That's not possible. So I don't know what. Okay, some nonsense coming up on the helpline. So the quantum entanglement is very funny situation there. So Albert Einstein says that no, they have a hidden fact, hidden something hidden between a secret they're sharing between these particles. So we have to investigate that. So that is where this Irish physicist come in the picture. His name is John Bell. John Bell is a Northern Ireland. He's from Northern Ireland. He used to work in CERN. Center for CERN is a big hadron collider, super fast collider in Sweden, and it goes through France and several countries it touches. So, when he was working. At that time it was not a 1964. It doesn't have the big hadron collider. It's a small CERN. It was working for the European nuclear commission. He came up with a profound theory that says that he came up with the idea. So what he did was, I wanted to give this girl any shot. Sometimes I give a random shots. I give a bulldog shot one day, then afternoon I give a Commodore shot. I will change left and right. She has no control which she's going to wear. Then opposite, if it is something they have hidden fact, there is no way that guy can follow. So that guy will not know. He will wear the same thing, so it will fail. So there is a hidden fact. We'll find out if there is a hidden fact is there or not. If he's wearing the same clothes, that means there is hidden fact failed. But there is a hidden fact, because if she wears the bulldogs, he wears the bulldogs again same day. That means hidden fact is failed. The hidden fact is, they have a hidden fact. There is hidden fact is there inside. So they failed because he's giving this. John Bell says that I'm going to give randomly different shots every 5 minutes, 10 minutes, and let us see what kind of things he's going to wear. So even that, he conducted a theoretical test, a game created it, and he proved there is no hidden fact. By doing these trial and error methods, you can check it out. There is a hidden fact or not. That's a profound theory in 20th century. If you're a physicist, you understand how powerful that theory is. He says that there is a universal something mysterious going on between these two. He proved beyond the doubt. They're not communicating through natural communications. They have some beyond, outside of the space and time, they're communicating. We don't know what that is. So he came up with a profound theory. So he died in 1964. He came up with it. And then he did not get the Nobel Prize. He died eventually. And then, brilliant scientist. He proved that John Bell's inequality theorem is one of the fundamental principles of the quantum physics. It is one of the fundamental things that quantum physics people really admire, the John Bell. So Alien Aspect and Dr. Clauser from Walnut Creek, where is next to Fremont. He proved, both of them together proved that what John Bell's experiment, yes, there is no hidden fact. There is mysterious thing is happening. God's effect. They are communicating through outside of our realm of the things. That is the mystery of the quantum entanglement. Even now, there is something mysterious about between them. We don't know. They communicate between each other. They don't communicate through any other known communications we know. It is something mysterious outside of this universe. Has to be outside of the universe. They both of them did not believe actually it's going to happen. When they started the experiment, they thought there is a hidden fact. But the experiment proved there is no hidden fact. It is surprising to a lot of physicists. Quantum entanglement is a very mysterious. One particle affects the other particle even a billion miles away. One is spin down, other is spin up, one other is spin down, other is spin up. Is this correlation? It is not a correlation. It is correlation is if you have a shoe, left side shoe, If I have a left side shoe, you have the you automatically have the right side shoe. That is a correlation. But the superposition, this kind of a quantum entanglement is until the last minute you don't know which one you have. You put it there, and then the other guy gets the opposite one. That is the strange about the quantum entanglement. In the last minute, it is deciding which way to go, which way to go, and the other one goes exactly opposite. That is the mystery of the quantum entanglement. They won the Nobel Prize. They won the Nobel Prize. So there is a mysterious communication between these on the so this communication, quantum entanglement, you can we don't know how they communicate, but you can use it to our advantage. We can do quantum teleportation. You see Star Trek 3, that what is that one, the doctor, that Captain Kirk does click it and he goes to someplace else. So that is a kind of a information quantum transportation teleportation they successfully did for 7,200 kilometers from China to Austria. Quantum satellite, Chinese quantum satellite. China is very advanced in the quantum satellites, in the quantum entanglement, quantum computers. So Antoine Zellinger did that. So three of them got the Nobel Prize. That is the story of nuclear, the prize of the nuclear. The Nobel Prize. Tomorrow I'm going to talk about Nobel Prize in medicine with Amy Butt. I hope she's going to come. So I'm going to talk about what is this mystery came from the universe. It's called proton therapy. I tell you how it came from the universe itself. So proton therapy is a big ass equipment. Have you seen that? It's a huge. There's no equipment bigger than this proton therapy equipment. I tell you how big it is. It is a weighs 220 tons. It's equivalent to almost 760 fully loaded Boeing 760. Is that big? That is a huge machine. It has a 21 miles of cables inside. You can spread out 21 miles of cables inside. Think about that. How many cables are inside? To protect the concrete radiation, 12 feet thick concrete walls protected by 12 feet thick concrete walls. To support the structure, 300 piers. You see that on the left side here. Huge piers, I think piers. So there is not only that piers, there is almost another building in the bottom. It's as big as the top building because it has to be seismic earthquakes and it has to withstand those kind of things. So they created another almost 200 feet up to the foundation. It is another building inside in the bottom. It's a huge structure. It is Emory University. I attended the first time when I attended first time. I attended first time when they did this proton therapy equipment. I did this. I attended that sales pitch. Very interesting. There's a lot of physics. So how does it work? So there is a proton. The size of the proton, I want to tell you. The hydrogen atom has one proton and one electron. That's it. So the proton. So this from Halayan Gao, Duke University professor, tried to measure the size of the photon. I tell you a comparison. If you expand the size of an atom all the way to the size of the planet Earth, the size of the nucleus, size of the proton would be the size of a football field. It's that small. Think about it. If you expand the atom to the almost at the planet Earth size, the size of the proton is extremely quadrillionth of a meter. Small proton. But that's the heaviest particle, heavier than electron. It's a positively charged proton is a positively charged heavy particle. It's a big boy. Okay. So what is this? So what is this for? For the cancer, cancer treatment, the three ways you can treat cancer is a surgery. Surgery, that's the first option actually, gold option, I think. Then next is chemotherapy, if it's a disseminated entire body. The targeted drug is a chemotherapy is the next one. Radiation is the tumors. If you can, the places that you cannot reach easily, cannot surgically remove it, you can do with radiation. These three methods. But I'm going to focus on the radiation part, things that's particularly complicated cases, like a brain tumors that you cannot reach, untreatable, inoperable brain cancers, brain tumors. So, but for that, I'm going to we have to take a law from the universe. So, cancer is the curse of the humans, but universe as the as creating a universal law is giving a cure for us. Cancer is the curse of the humanity, but universe is giving a universal law is giving a treatment for the cancer. I tell you how it does. So I'm going to play a video. This video will tell you a little bit about the how the so they wanted to create right after the Big Bang. They want to create a, a simulation in the collider, hadron collider simulation. See that what happens in the beginning of the universe, right at the beginning of the universe, right after the Big Bang, how the particles are formed, how they interacted each other. They want to know. So they created a experimental thing, hadron collider in Sweden. That's called CERN. It is a collider that created to create conditions right after the Big Bang. So I'm going to play a video. Watch this.
Insignificant though this bottle of compressed hydrogen gas looks, it marks the beginning of the world's largest and most powerful particle accelerator chain, culminating in CERN's spectacular Large Hadron Collider. Hydrogen atoms from this gas cylinder are fed at a precisely controlled rate into the source chamber of a linear accelerator, CERN's LINAC-2, where their electrons are stripped off to leave hydrogen nuclei. These are protons and have a positive charge, enabling them to be accelerated by an electric field. Their journey to eventually take part in ultra-high energy collisions similar to those following the Big Bang can now begin. This initial acceleration has caused LINAC-2 to be likened to the lumbering first stage of a huge rocket. By the time this packet of protons leaves LINAC-2, it'll be travelling at 1/3 the speed of light. It's about to enter the booster, stage 2 of the rocket if you will. In order to maximise the intensity of the beam, the packet is divided up into 4, one for each of the booster's rings. Straight acceleration is now impractical, and the booster is circular, 157 metres in circumference. In order to accelerate the packets, they are repeatedly circulated, and the electric field is now pulsed, in the same way that you push a child on a swing each time they reach a certain point. Magnets exert a force on the passing protons at right angles to their direction of motion, and so powerful electromagnets are used to bend the beam of protons round the circle. The booster accelerates the protons up to 91.6% of the speed of light and squeezes them closer together. Recombining the packet from the 4 rings, it's then flung on into the proton synchrotron, by analogy stage 3 of our rocket. Let's just follow 2 such proton packets. The proton synchrotron is 628 metres in circumference, and they circulate for 1.2 seconds, reaching over 99.9% of the velocity of light. It's here that the point of transition is reached, a point where the energy added to the protons by the pulsating electric field cannot translate into increased velocity, as they're already approaching the limiting speed of light. Instead, the added energy manifests itself as increasing mass of the protons. In short, the protons can't go faster, so they get heavier. The microscopic kinetic energy of each proton is measured in units called electron volts, and now the energy of each proton has risen to 25 giga-electron volts, or GeV. The protons are now 25 times heavier than they are at rest. The packets of protons are now channeled into stage 4, the superproton synchrotron, a huge ring 7 kilometers in circumference, designed specifically to accept protons at this energy and increase it to 450 GeV. Soon, the packets of protons will be energized sufficiently to be launched into the orbit of the gigantic Large Hadron Collider, or LHC, which lies between the Jura Mountains and the Alps, and straddles both France and Switzerland. Lying deep underground, it has a circumference of 27 kilometers. There are 2 vacuum pipes within the LHC containing proton beams travelling in opposite directions. Using ultra-sophisticated kickers to synchronize incoming packets with those already circulating, one vacuum pipe has injected into it protons which will circulate clockwise, and the other protons which will circulate anti-clockwise. The counter-rotating beams cross over in the 4 detector caverns, where they can be made to collide. The energy of the collision is double that of the individual opposing protons, and it's the debris from these collisions that is tracked in the detectors. For half an hour, the SPS injects protons. Finally, there are 2,808 packets. During this time, the LHC adds extra energy to each proton, whose velocity is now so near the speed of light that it goes round the 27-kilometer ring over 11,000 times each second, getting a boost of energy at each revolution from the pulsed electric field. Finally, each proton has an energy of 7 tera-electron volts, and they're 7,000 times heavier than at rest. The magnetic force needed to keep the beams bending to the ring is so enormous that nearly 12,000 amps must flow through its electromagnets. This is achieved by making the LHC colder than outer space, so that its magnets become superconducting. Now the protons are ready to collide in the detectors. A steering magnet finally brings them onto a collision course. The total energy of 2 protons colliding in the LHC is 14 tera-electron volts and reproduces similar states to moments after the Big Bang. Particle tracks from these collisions will be analysed by computers connected to the detectors, and it's hoped these tracks will give a new insight into the very birth of our universe, how our universe has evolved, what governs its behaviour today, and where it's going in the future.
Okay, so you saw that it's a beginning of the universe, that cyclotron came from that to find the conditions at the beginning of the universe. That's what the cyclotron was born. Actually, cyclotron was born before that. I'm going to tell you a little bit about. So, but how does it relate it to the proton therapy? That's what the question is. So I'm going to tell you a funny guys. I'm going to show you 2 funny guys. They have they share the same barber, but their husband, there's a father and a son, Dio. So they share also Nobel Prize. These are only father and son duo sharing the Nobel Prize in the history of the Nobel history. So that father and son, William and Henry Bragg, they're not other than they did quite a bit of contributions in the X-ray crystallography. They won the Nobel Prize for that. But they also found something about these protons. They do funny things, or strange thing it does. I tell you what that's called. It's called they discovered something interesting. It's called a Bragg peak. Bears their name. The Bragg peak is when you go all of us when you're driving fast, and he saw a stoplight, a red light. All of a sudden, he didn't. He saw the red light and he stopped it. There was a jerk comes out of the stoplight. So it is a jerk that comes out, right? So the energy transferred into kinetic energy and moved into the jerk. That's what the energy was deposited in your car at the when you stop it. When you stop it, the kinetic energy that you stop it all of a sudden transferred into a kick. That is a kick. So protons does exactly the same. It goes there, it goes normal speed, and then when it before it stops, it gives a kick and then falls immediately to zero energy wise. So the natural phenomena of that, the characteristics of the physics, they use it to our advantage, is that if the tumor is exactly placed in the peak, then all the energy is deposited there, and the tumor gets destroyed. Brilliant idea, right? That's what the Bragg peak was used by physicists to this gentleman came up with the. So what is the Bragg peak does? If you see conventional, I need to explain how the conventional radiation treatment works. If you send a gamma rays, usually they send a gamma rays, gamma photons. If they go straight, they hit your skin first. That's where the maximum energy deposited. So healthy cells get the bigger dosage of the radiation. Then by the time it reaches the tumor, it weakens. The radiation weakened, and the tumor is getting a very least amount. So that's a problem, right? So some of the hard to reach things, that is, so you're getting that's why people get sick, because your radiation, your healthy cells are getting a bit more radiation than the tumor itself. So they came up with, so this proton treatment is, it does normal, goes away, and then when it stops, it gives that jerk. I told you that stop jerk. Only protons can do that. And it goes there and blasts off, and they can blast it off with the tumor with the powerful energy from the proton stopping. Coming to the rest, it gives you a Bragg peak energy and destroys the tumor. So if it is a Bragg, the tumor is right there. The Bragg peak is that there. So you keep on bombarding with the Bragg peak with the different directions. So your healthy cells are getting definitely less radiation, and the tumor is getting the bigger radiation, is deposited, blasted off with a much more stronger radiation than stronger destructive power for the tumors than the traditional radiation. So very powerful. They found particularly pediatric cancers, they cannot, people who are very sick cannot take the radiation treatment. You can use this power, proton proton therapy, use the advantage of the physics of that, and use the proton to blast it off these tumors. So who did, so what they do, if they want to do, instead of moving the gantry, it's a huge, you saw the big one, is a huge, it's almost two-story building, the gantry itself. So you don't want to mess with all this, you don't want to move those parts. What they came up with a clever idea, you put there, they wanted to attack your tumor, they put a water tank in between. Water is a good absorption of energy. So it tells you how much water they can put it there. It gives you that much energy at the end. Where to stop, the proton to stop. When it stops, it releases the big energy, right? That's an advantage of that. And so they can use as a controlling mechanism, they use a water tank. That is a very clever way, came up with this one, multi-million dollar equipment. This is a multi-million dollar equipment, this one, you know. So, but they came with a water tank, can do that trick. So it is a really amazing technology. It came from actually Ernest Lawrence cyclotron that was invented in the Lawrence Livermore, actually named after him. He was in the University of Berkeley, UC Berkeley. He did this cyclotron. That's Robert Oppenheimer, the Manhattan Project guy. So They are the first ones who came up with the cyclotron. They didn't know cyclotron. They wanted to accelerate the particles to find out what's going on in the what are the constituents of the particles itself. So they want to find out about that. So it is it is a proton therapy is a very powerful. Um, these guys invented the cyclotron, but the actually father of the proton therapy is a Robert Ruthborn Wilson. He was born in Frontier, Wyoming in 1914. He was a cattle rancher. He spent a lot of time in cattle fields, in a cattle ranch. Think about that. The mind, how mind is powerful. You can come in a small village. You can come from different parts of the remote corners of the world. He came from a cattle ranch and he invented. He came up with a brilliant idea. Why can't we use to treat cancers the cyclotron, that the speeding mechanism that you do? They're finding out. Let them find out the beginning of the universe. I'm going to find the tumor treating the cancers. So he became a founding member of the Fermi Lab in Chicago. He created the first proton lab up there, proton therapy center in, in the Fermi, next to the Fermi Lab in near Chicago. That is, he was Robert Wilson is the father of the proton therapy. Actually, they gave a lot of awards on his name. So that cyclotron used it for the treating cancer. He came up with this idea. Hey, why can't we use a cyclotron where you are accelerating the particles? We take the protons instead of using let you find out the beginning of the universe, what's going on. But I'm going to take care of the humanity. I will cure the. You can find out the cure for the cancer through this process. That's what he did. So he uses the cyclotron to come back, and hit the tumor with the protons. It's a brilliant idea. It came out. Now, how many centers are there? It's a very new. This technology is extremely new. There's only 40 centers in the whole United States. Um, just 40. Yeah, Atlanta is one of them. Chicago, of course, that's where it started it. I attended the first sales pitch for the Emory University. They're giving how big building they have to build it and all those things. It's a huge building. It is really a major construction undertaking. So far, the 200,000 people were treated through proton therapy. It is still ongoing research. It's a very powerful way of treating cancers. Still, we don't know cancer is one of the you know nagging diseases, but that we don't understand. We even if we understand it, we don't know how to control. A lot of things is happening with the cancer. We have to do multi-pronged approach to treat cancer. So this is the proton therapy centers. We want, instead of spending money on the wars, we want to spend on the saving humanity, creating more of these therapy centers. Be good. Use the advantage of the physics. I'm teaching physics related to healthcare to the future presidents. So that's my goal. So thank you all. Thank you for attending. So is a universe actually created life from the just a collection of particles and gave, and then we acquired diseases. But the universe also gave a laws that you can treat those diseases, but you have to. Our job is to discover them. We are on the journey to discovery. Thank you for attending. I really appreciate it. Sorry, the guest is, I don't know what happened. I hope um, sometimes this is I do my best. It is not easy, but this is the one doctors could learn. It's more important is how these things work. If you have basic understanding of this, then you get appreciation. Then you can suggest to patients sometimes, hey, I heard about it. A lot of primary care doctors may not know everything about proton therapy, what it does. So it is a very powerful tool for the humanity. It's a very expensive equipment. It costs about $100,000 right now, the treatment. So let us work. Let us bring up the humanity, uplift the humanity through loss of universe, loss of physics. Thank you for watching. I'm going to play. You can buy. These are the, technology people took control of medicine. Actually, these are the people we need to really celebrate. These are the true gods of the sciences, not the demigods of technology. These are the true gods, and then they saved our humanity. When the crisis comes, they will come. These people really does show up. These people really gave the gave the uh, during the COVID or any other place that these kind of a science will give us solutions. Technology is a tool, no question it helps. It's helping you, helping me, and creating a problem same time. But I hope you bear with me. I want to make this program very good. Thank you all for joining and watch and support this thing, buying the t-shirts and everything there. That I have a lot of these scientists. I have cups and t-shirts and mugs. By promoting this, by buying this, you're promoting the science and humanity better.
We are retelling their stories through our patented designs that can be worn on scrubs, t-shirts, printed on conference bags, and endless other promotional materials. Daily Wear for Medicine is the first ever of its kind to create curiosity in medicine through visual art. We at MedBricks are celebrating unsung heroes of the past who made enormous contributions to the field of medicine through our unique campaign called Daily Wear for Medicine. You can wear it, carry it, and give it.